Okay, today we will be learning about inequalities. We will first of all start with our definitions, and the first two should look familiar, the additive property of equality and the multiplicative property of equality. Okay, before we do those, I just want to go over some notation. So we have inequalities, and I know they're all random sizes on the left. I don't know why they're so big and so small, but that's just, anyway, that's how they ended up. So the first thing in notation is set builder notation. You'll notice that this uses our set notation. It has curly brackets. And so the first thing that you say is the curly bracket. So it's the set of all x. Remember that vertical line means such that. So it's the set of all x such that. And then we list whatever conditions our x has to meet. So we just drop the inequality right in there. So the inequality and set builder are essentially identical, but the set builder is just a little more formal. Okay, next, if we were to put that information on the graph, okay, we'll do more set builder first. So again, the set of all x such that, and then we plop the inequality in. The set of all x such that, now I could go ahead and put 1 less than x, but usually if we only have one inequality sign, we want to list the variable first. So I'd say the set of all x such that x is greater than 1, because that means exactly the same thing as 1 is less than x. And it's just a little bit more comfortable. We're a little more used to seeing the variable first. For the next one, the set of all x such that x is less than 3. We just plop the inequality in there. This next one, the set of all x such that 1 is less than x is less than or equal to 5. Now I told you if you only have one inequality in there, you list your variable first. If you have two inequalities, that is called a compound inequality. And if you have a compound inequality, you want the least number to go on the left. So if we have 1 and 5, well, 1 is less than 5, so we put the 1 and then the less than x and then the less than or equal to 5. For this next one, negative 10 is less than negative 4. The way that we can kind of see that it's backwards right now is we always want our compound inequalities to have less than signs or less than or equal to signs. So we are going to just rewrite that. It's exactly the same thing, but it's just a little more traditional. The set of all x such that negative 10 is less than x is less than negative 4. Okay, now if we're going to look at what that looks like on a graph. For the first, x is greater than or equal to negative 2. So at negative 2, I'm going to put a filled in circle. Since x actually can equal negative 2, it's greater than or equal to negative 2. I want to fill in that circle. And then since it's greater than, I'm going to shade going up. Okay, for the next one, x is less than or equal to 5. Since x can equal 5, I would put in either a filled in circle or what your book uses, and it's by far the minority. I've seen it in other books, but not many. Most books use the circles. We could use a bracket. A bracket means that I'm going to include that number. It's the same thing as a closed circle. And then since it's less than or equal to 5, I shade to the left because I want all numbers less than or equal to 5. Okay, if x is greater than 1, I'd either do an open circle. That's what most of us are used to using. I use an open circle because I can get really close to 1, but I can't actually equal 1, so I don't want to fill in that circle. And then since x is greater than 1, I shade all the numbers that are greater than 1. If x is less than 3, now I can do an open circle, that's fine. What your book uses, and a few other books, is a round parenthesis. So a square bracket means I'm including the number. A round parenthesis means I'm not. You can choose either of these notations. I don't care which one you use, but most people use the open and closed circles, but your book does use the other, so I want you to see both. Since I'm looking at numbers less than 3, I shade this way. Okay, now I'm looking for numbers that are greater than 1 and less than or equal to 5. So that means at 1, I'm going to have an open circle, and at 5, I'm going to have a closed circle, and I want all the numbers that are greater than 1 but less than or equal to 5, so I shade in between. Now if I were to do the same thing with parentheses and brackets, we'll do that on the next one. Negative 10 would have an open parenthesis. Negative 4 would have an open parenthesis because I don't have an equal sign on either one of those inequalities. And I want numbers that are greater than negative 10, so that goes to the right of negative 10, and less than negative 4, so that goes to the left of negative 4, so I'm shading in between again. Okay, the last bit of notation is our interval notation, and you'll see why the parentheses and brackets tend to make a little more sense all of a sudden. So for this first one, I want all numbers starting at -2 and then going up forever and ever and ever. So my interval notation, I'm sorry, I start at the bottom. Okay, so my interval notation on the bottom, I want all numbers starting at -10 and going up to -4, but I don't want to include -10 and -4, so I use those round parentheses. Okay, the next one up, I want all numbers between 1 and 5. I don't want to include 1, but I do want to include 5. So 1 gets a round parenthesis and 5 gets a square bracket. So you'll notice that if you use square brackets and round parentheses on your graph, then it's going to be pretty easy to write the interval notation. It's not hard in either case, but that's one reason why the round parentheses and square brackets are used, is just to make it more consistent with the interval notation. Okay, now if we look at the next one up, we have all numbers that are less than 3. So if I look at the number that's the furthest to the left, there isn't one. I could go down as far as I want, all the way down to -infinity. Now a note on infinities always get round parentheses. They never get a square bracket because infinity is not actually a number. You can't actually include it. So that is how that one works. Okay, the next one, I want numbers starting at 1 and going up as far as I can think. So I'd start at 1, go all the way up to infinity, and both of those numbers would have round parentheses because I'm not including either one. I can't include 1 because it has an open circle. I can't include infinity because infinity is not a number. Negative infinity is always on the left. A positive infinity is always on the right because the numbers in your interval notation, you have the least number on the left and the greatest number on the right. Okay, this next one, the least number would be negative infinity, so I list that first. It gets a round parenthesis because I can't include infinity, all the way up to 5, and then I'd have a square bracket because I'm going to include 5. And lastly, we'd start at -2. I include -2 so it has a square bracket, and up as far as I can think, and that's infinity, and I use a round parenthesis. So those are the 3 ways that we write our interval notation, or all of our inequalities. Okay, for this last part, I just want to fill in. I've given you one thing in Set Builder, and you have to find the graph and the interval notation. When I give you the graph, you have to find the other 2, and when I give you the interval notation, and you have to find the other 2. So go ahead and pause this video and make sure you can fill those in, and then come back. All right, now that you've done those on your own, so for this one, we have Set Builder. If we go to the graph, we are going to have 2/3, which is about right there. It's an open circle since it does not have an equal sign on that inequality. And then less than or equal to 3, so 3 gets a filled in circle. I'm looking for numbers that are bigger than 2/3 and less than or equal to 3, so I shade in between. My interval notation, the least number is 2/3. So that goes on the left. That gets a round parenthesis because I'm not including that number, and it goes up to 3. And I'd use a square bracket because I am including that number. Okay, for this graph now, if I look, that open circle is at -3. So for Set Builder, I'm going to have the set of all x such that x is greater than -3. It's greater than because that circle is open, and it's also greater than because I'm looking at numbers that are greater than it. For interval notation, I'd have -3 all the way up to infinity, and both of those would have round parentheses. Okay, if I have -2, 1. My Set Builder is the set of all x, and you could use a variable other than x. It would be fine to say the set of all y such that, and list your inequality in terms of y. But it's the set of all x such that, then we'd have -2 is less than or equal to x or y or whatever variable you've chosen, which is less than 1. The less than or equal to is because of the square bracket. The less than is because of the round parenthesis. And then look at that x. It's greater than or equal to -2, and it's less than 1, so it's right in the middle of that interval, which is right where you want it. So there's my -2, there's my 1, and I shade in between. That is all of the different ways that you will express your answer once we start solving linear inequalities. So that is the end of notation, and we will now start to solve them.